Assalamualaikum and hi, my name is Danish Zaffrin Shah bin Mama Irsyad. Today I would like to share with you guys about how to answer questions 1. Let's read question first. A supermarket has 2 customers waiting for their purchases at counter 1 and 1 customer waiting to pay at counter 2. Let's X1 and X2 denotes the numbers of customers who spends more than 50 ringgit on groceries at their respective counter. Suppose that X1 and X2 are independent binomial random variable with the probability that a customer at counter 1 will spend more than 50 ringgit equal to 0.2 and the probability that a customer at counter 2 will spend more than 50 ringgit equal to 0.3. Okay, the question first is state the joint probability mass function of S1 and S2 based on the case study. For counter 1, we know that D is the binomial random variable which is N is equal to 2 and P is equal to 0.2, and also for counter 2 is N equal to 1 and P is equal to 0.3. So S1 and S2 independent, hence the probability mass function of S1 and S2 is equal to function S1 times function S2, which is it can be 2 choose S1 times 0.2 power of S1 times 0.8 power of 2 minus S1 times function S2, which is 1 choose S2 times 0.3 power of S2 times 0.7 power of 1 minus S2. So the joint probability mass function of S1 and S2 will be like this, which is S1 is equal to 0, 1 and 2, and also S2 will be 0 and 1, which is find the joint PMF of S1 and S2 in tabular form. We know that we have function of S1 and equal to 0 and S2 equal to 0 until S1 equal to 2 and S2 equal to 1. So we should put the S1 and S2 into the formula, and it will be the value like this, which is the function of S1 equal to 0 and S2 equal to 0 is 56 over 125, and the value for S1 equal to 0 and S2 equal to 1 is equal to 24 over 125, and until we put the number and the function of S1 and S2, S1 equal to 2 and S2 equal to 1 is equal to 3 over 250, and we put the value into the table in the tabular form, which is it will be like this. We move to the question 3, which is find the marginal distribution of S1 and S2 in tabular form. So from that this tabular form joint PMF, we should add the more column, which is for function S1 and function S2, the value. So how to get the value 7 over 10, which is 56 over 125 plus 28 over 125 plus 7 over 125 is equal to 7 over 10, and it will be the 3 over 10, it will be something like that. And for function F2, S2 is 56 over 125 plus 24 over 125, and it will be 16 over 25, and 8 over 25 and also 1 over 25. Probability that not more than one of the 3 customers will spend more than 50 ringgit. So we know that S1 plus S2 must be less than or equal to 1, which is whether 0 plus 1 or 0 plus 0 or 1 plus 0. So it will be probability S1 plus S2 less than or equal to 1 equal to probability S1 equal to 0, S2 equal to 0 plus S1 equal to 0, S2 equal to 1 plus S1 equal to 1 and S2 equal to 0. And we should put the value in the function, the formula. And the value will be 56 over 125 plus 24 over 125 plus 28 over 125. And the total will be the probability of S1 plus S2 less than or equal to 1 is equal to 108 over 125. Determine the mean and variance of W equal to S1 minus 2 S2 plus 5. So we know that the both of S1 and S2 is the binomial random variable, which is for S1 is N equal to 2 and P equal to 0.2, and for S2 N equal to 1 and P is equal to 0.3. So to find mean for binomial is N times P, and variance for binomial is N times P times 1 minus P. For this case, for mean of W is equal to 3 times mean of S1 minus 2 times mean of S2 plus 5, and we put the value to that formula, and it will be the mean for W is equal to 28 over 5 or 5.6 is same. So for variance, we should do the formula for this case, which is variance of W is equal to 9 times variance of x1 plus 4 times variant of x2 plus 2 times 3 times minus 2 times covariant of x1 and x2. And the statement said the above say x1 and x2 are independent, hence covariant of x1 and x2 is equal to 0. And we should put the formula, we should put the value in that formula, and the variant for VW will be 93 over 25, or for decimal it will be 3.2, 3.72. Okay, that's all for me for question number 1. So we move to the question number 2, and I will pass the button to the Muhammad Irsyad, my partner, to explain more about how to answer question 2. That's all for me. Thank you.
Okay, now for the question 2. So we will start the question 2 with the reading the question. So let Y1 denote the weight in ton of the bulk item stock by the supplier at the beginning of the week, and suppose the Y1 has a uniform distribution over the interval 0 to 1. Let Y2 denote the amount by weight of the item sold by the supplier during the week and given the conditional distribution of Y1 and Y2. And then the question is find the joint function of Y1 and Y2. So now we have this function, we can just use this. We will need to use this formula and to find the function Y1 and Y2. So we will just transfer the Y1 to the other side and we will get this. So we need to know what the function for Y1. So we know that the function for Y1 is equal to 1, and the function Y2 equal Y2 to Y1 equals to 1 over Y1. How we know the function Y1 equals 1? Because the Y uniform 0 to 1, and we will put it in this formula, and we will get the function Y1 equals to 1. And this we will get if we put the figure in the function. Sketch the base of the surface based on the case study. So when we calculate the function on the question above, we will get the function x-axis is y1 and y-axis is y2. So we will sketch this all this below, and then we will label this line 0 to y2 to y1 and to 1. Hence the graph of the joint probability density function for y1 y2 uniform 0 to 1. The answer in B satisfy the assumption of joint probability density function. So we should this question should satisfy the following condition: A, the function x y more than 0 for all x and y, and B, function dy dx when the function x y equals to 1. So when we need to satisfy this B, we need to double integrate it to when we want to satisfy it. So A, we will know that function y1 and y2 equals to 1 over y1, and then we just put the limit, the range 0 to y2 to y1 and to 1, and then we just put the answer the figure in the 1 over y1, and it will just around the range 0 to 1. So it will be satisfied. So the problem is B, when we need to integrate the function. So we need to integrate it one by one. And now we have 1 over y1. When 1 over y1, when we integrate it, we will get y2 over y1 when the limit 0 to y1. Because of first we integrate it with the dy2. So then we will put the value y1 to 0 to y1, and we will get this y1 over y1 minus 0 over y1. And then we will get 1 minus 0, and we will get 1. So now we need to integrate the 1, and then if we integrate 1, we will get y1 when the limit 0 to 1, and then we just put the figures 1 minus 0, and we will get 1. So hence if y1 y2 does satisfy the assumption of joint probability density function. Okay, for the D question, if the supplier store a half ton of the item, what is probability that she sells more than a quarter ton? So now we have a half ton of the item. We know is a y1. So the y1 is equal to 1 over 2. So then we need to find y2. So probability y2 conditional y1 when y1 equals 1 over 2 is 1 over 2. Then we put in the function probability y2 more than 1 over 4 conditional 1 when y1 equals 1 over 2 equals to we need to integrate the function y2 conditional y1 equals to 1 over 2 when the limit 0 to 1 over 4. Then we will get this 1 over 2. We need to integrate it, and when we integrate it, we will get y2 over 1 over 2 when the limit 0 to 1 over 4. We put in the figure, when we put the limit in the y, and we will get probability y2 more than 1 over 4, conditional y1 equals to 1 over 2 equals to 1 over 2. Okay, for the final question, if a known that supplier sold a quarter ton of the item, what is probability that she had the stock more than half ton? So now we know the quarter when supplier sold, we know sold is referred to y2, then is y2 equals to 1 over 4. Probability y1 more than 1 over 2, conditional y2 equals to 1 over 4. So in the function, we will use this formula, and then we need to find the function y2. So when the function y2, we need to integrate 1 over y1, and when the limit y2 to 1. When we integrate the 1 over y, we will get ln y1 when the limit y2 to 1. And then we will get ln 1 minus ln y, and we will find out ln 1 is equal to 0, and then the function y2 is equal to negative ln y2. So that we put the figure in the formula, and then we know function y1, y2 equals to 1 over y, and over with the function y2, that is that negative ln y2, and we will get the function is 1 over negative ln y2 times y1. So the probability y1 more than 1 over 2, conditional y2 equals to 1 over 4, equals to function y1, conditional y2 equals to 1 over 4, when the limit 0 to 1, 0.5 to 1. When we integrate it, we put the figure that we found that above, 1 over ln y power of negative 1 times y1, when limit 0 to 1, we will get this. Don't forget to insert the value of y2 when y2 is equals to 1 over 4. And then we will get 1 over ln 4 times y1. And then we integrate it, when we will get ln y1 over ln 4 when limit 0 to 0.5 to 1. And then we will get this answer.